Okay, today we're going to review the homework assessment A1, and I'm going to do that by working a couple problems from each section. The first section here, let me zoom in a little bit. It's testing for a function algebraically. So to do that, we're going to have to solve for y. Now, if we get y equals one equation, then it's usually going to be a function. So let's do two of these. Let's do number 17, x squared plus y squared equals 4. So this is number 17. Put it down a little bit. X squared plus y squared equals 4. If I solve for y squared, I get y squared equals 4 minus x squared. But I need y, not y squared. So I'm going to take the square root of each side. So number y equals the square root of 4 minus x squared. Now, since I'm going backwards, I could have started with a negative number here, because a negative number squared would be a positive number. So I have to write this as plus or minus. That gives me two equations. 4 minus x squared, this would be the positive value. And the negative would be negative square root of 4 minus x squared. Now, just the fact that I got two equations here means that it's not going to be a function, but let's graph it and see if we can confirm it graphically. So I'll turn this on, clear out the equation editor, and I'll put in 4 minus x squared. Then I'll put in negative square root of 4 minus x squared, and I'll graph it. Now when I graph this, you see I get a circle, and that fails the vertical line test, so that would not be a function. Now let's look at another one here. Let's look at number 21. Now number 21 says 2x plus 3y equals 4. So 3y equals negative 2x plus 4, and y is equal to negative 2/3 x plus 4/3. Now this has y equal to one value of x. So if I put this in and look at the vertical line test, I'll see that it should pass it. So I'm going to put in negative 2 divided by 3 x plus 4 divided by 3. Now look at the graph of that. And you see that's a linear graph, and it passes the vertical line test. So this one is an equation, is a function rather. Now how do you write your answer? For this one you would write this is not a function because two values of x, let's put it this way, a value of x maps to two y's. Now you can also say it fails the vertical line test. And the second, number 21, this is a function because x maps uniquely to y. And you're done. Now the next section has to do with evaluating a function. Now when we're evaluating a function, we're just going to plug in some values here. So I'll do number 29. So we're given the equation f of t equals 3t plus 1. Part A says that t is going to be 2, so we're looking for f of 2. This means since t is 2, we'll take the t out, put in a 2. And now we have a 7. Point B says the value of t is going to be negative 4. So f of negative 4 will be 3 times negative 4 plus 1. So this is negative 12 plus 1. And we have negative 11. Point C is kind of literal equations. Kind of literal here. We're looking for f of t plus 2. So we're going to take the t out of the original equation and replace it with t plus 2. So this becomes 3 times t plus 2 plus 1. Now we have to distribute the 3 across the t and the 2, so we get 3t plus 6 plus 1, which gives us 3t plus 7. Now the table down here, we'll do that a little differently. We can put that into y equals and just go to the table and pull our values out. So I'm going to put in 1/2 the absolute value of x plus 3 and space out. And I'm going to graph that and see what it looks like. And now let's look at the table and pull our values out. So when x is negative 5, I get a 1. When x is negative 4, 0.5 is 1/2. Negative 3 gives me a 0. Negative 2 gives me 1/2 again. And negative 1 gives me 1. And that's done. Okay. Now for the next section here, 51 through 54, we're looking for the zeros of the function. We need to know what value of x makes this equal 0. Now, some students looked at that and plugged 0 into the equation. It's not quite what they're asking for. We need this to, the value of x to make the entire thing equal 0. So let's look at number 53. So 53 says f of x equals 3x minus 4 divided by 5. So I want 3x minus 4 divided by 5 to equal 0. So if I multiply by 5 on each side, I end up with 3x minus 4 equals 5 times 0, which is 0. Move the 4 over, I get 3x equals 4. Divide by 3, and I see that x equals 4/3. So to answer the question, I can write when x equals 4/3, the output is 0. Okay? Now, in 55 through 60, we're looking for the domain of a function. Now, in general, the domain is all real numbers, and then we start taking away things that are not part of that domain. And there are two things we're going to be concerned about. We can't divide by 0, and we can't find an even root of a negative number. So we have to be concerned about this one, which is a fourth root. We have to be concerned about this one, which where we're dividing with the variable. Same thing here. So number 57 and 58, we have the same situation. In 57, we have h of t equals 4 divided by t. Pull that down a little bit. And since we can't divide by 0, that means t is not equal to 0. So the domain would be all real numbers. And that symbol there means all real numbers except 0. And similarly, for number 58, we have s of y equals 3y over y plus 5. Now we're concerned about the numerator, but the denominator, once again, we can't divide by 0, so y plus 5 can't equal 0, so y can't equal negative 5. And the domain is all real numbers except negative 5. Now, there are other ways of writing this. You could have written this as negative infinity to negative 5. Now notice I did not use a bracket here because negative 5 can't be part of the domain. And negative 5 to plus infinity. I'm going to put a plus on that. That's another way of writing it. Okay, let's talk about 7 through 10. Again, we're looking at domain and range, but we're going to get it from a graph this time. Let's do number 7. I put arrows on this because this is going to continue forever, indefinitely. But as it's coming down, it's coming at something of an angle, so it's spreading out to the left and it's spreading out to the right. So that means our domain in this case, for number 7, the domain will be negative infinity to plus infinity. The range, on the other hand, it goes down to negative infinity here, but when it's going up, it stops at 1. So the range, this is domain, this is range. It's going to go from negative infinity up to 1 and stop there. Now, some people are overlooking the third part of this. It says, what is f of 0? Well, you have to read the graph for that. You find 0 on the x-axis, and the y value is 1. So f of 0 equals 1. Number 19 and 20. Now here we're going to use the vertical line test to decide whether this is a function or not. Now the vertical line test says that any vertical line can only cross that function one time if it's a function. So we can see that applies here. Any vertical line we draw only crosses once. Over here, if I draw this vertical line, it crosses twice. So this is a function. It only intersects one time. Over here, it intersects twice, so it can't be a function. Now going to the back, we're talking about transformations. Now you have a handout in your journal that lists the transformations. Now this is asking for the parent function, so why don't I do number 53. 53 says g of x equals 3 plus 2 times x minus 4 squared. Well, this is a square here, so the parent function would be g of x equals x squared. Now let's talk about the transformations. That 3 is positive, so we're adding 3 outside of the argument, so that means it's going to 1, move up 3 units. Now when we move to the 2, we're multiplying 2 times the argument, so that's going to be a vertical stretch. Vertical stretch. By a factor of 2. And then the last thing we're going to look at is what happens inside the argument. Now this is counterintuitive here. You would think if you're subtracting you would go to the left, but inside the argument you go to the right. So this is move right 4 units. Okay. Now let's do one more. Let's do number 56. Well, 56 is g of x equals negative 1/2 x plus 1 squared. Now once again, the parent function is this square here, so the parent function would be g of x equals x squared. As we examine this going from left to right, we have a negative sign, so that's going to be a reflection over the x-axis. Number 2, we're multiplying the argument by 1/2, so that's going to be a shrink since the 1/2 is less than 1. So we have a shrink, vertical shrink, by a factor of 1/2 scoot it over so you can see it. And number 3, we're inside the argument, so now we're looking at adding 1. Now, once again, adding makes you move to the left, so we're going to move left 1 unit. Okay. Now that takes care of the transformations. In the next section, we're talking about arithmetic combinations of functions. And so for these, we're going to be given a number. And whatever number we get, we're going to plug that same number into each function. And when we get the results of that, in this case, we're going to add it together. So let's do number 19. 19 says f plus g of 3. Now, since it's arithmetic, we're going to plug 3 into f and 3 into g. So f of 3 will be 3 squared. X is now 3, so we square that, minus 1. So this becomes 9 minus 1, which is 8. G of 3 is x minus 2, so 3 minus 2 is 1. And now we're going to add those. F plus g of 3 equals 8 plus 1, which is 9. Let's do one more of these. Let's look at number 23. Now 23 is fg. Now that means multiply. So fg of 6. So f of 6 is going to be 6 squared minus 1. So that's 36 minus 1 is 35. And g of 6 is going to be 6 minus 2, which is 4. So f times g of 6 is 4 times 35, which is 140. And that takes care of the arithmetic. Now the last section on here is composition. Now composition is different from arithmetic. Composition, you work from back to front. And in this case here, I gave you a number. When you did it on the homework, it was a literal insertion, but on this, we're going to use a number. That number was 3. So let's look at number 43 on this one. So what we're looking for is part A is going to be f composed of g of 3. So for this one, I'm going to plug 3 into g. So g of 3 is 5 minus 3, which is 2. Since 2 came out, I'm going to plug that into f. So f of 2 would be 3 times 2 plus 5. So this is 6 plus 5, which is 11. So the composition, f composed of g of 3 equals 11. Now for part B, we're going to reverse that, and we're going to do g of f of 3. So I plug 3 into f first. F of 3 is going to be 3 times 3 plus 5, which is 14. 14 now goes into g. G of 14 is going to be 5 minus 14, which is negative 9. And then for part C, we have f of g of 0. So g of 0 is going to be 5 minus 0, which is 5. F of 5 will be 3 times 5 plus 5, which is 20. So f of g of 0 equals 20. Now use these 4 examples and try to work the rest of the problems on the test, and then we'll retake the test when you feel you're ready. Okay, that's it.